Hi guys, how are you? So this is just the second part of my Le Chatelier clip here. I just wanted to do a couple of examples of questions as much as I can. It's not a calculation thing, it's more about understanding it, but I thought I'd talk through this sort of process of how to understand it, if that makes sense. I don't know if this is a whole lot of use, but I'm going to give it a go anyway, right? So this is 2019, question 11, part B. This is the part now on Le Chatelier, okay? So in this question, it at the very part, so this is part B, the very last part, okay? So elsewhere I've done the calculation for this, and you can check that up. But now we're just looking at the very last part where it says increasing the pressure on this equilibrium mixture at 1200 degrees Celsius intensifies the colour of the mixture, but does not change the percentage dissociation of bromium chloride. And then it says explain. Right, so how would you do that? Well, it's always a good idea when you're asked a Le Chatelier question to write out your KC and have it there, all right? Now, what's really important to remember here is that increasing pressure, remember this is a gas, this is a gas, and this is a gas, okay? And you're told that in the question. Increasing the pressure pulls all those molecules closer together. So that's one reason why they're going to be a more intense colour, because there's more particles per volume. Okay, so increased pressure means there's more of an intense colour because the gas mixture is more concentrated. But what's really important here is to remember that Kc only changes when we change concentration. It doesn't change when we change pressure, okay? The system will adjust to maintain Kc. So Kc will always stay the same. So if you increase the pressure, it's not actually going to affect Kc one way or the other. Kc will remain unchanged. It only changes for concentration. That's all you need to say for that. Is that okay? I want to have a look at another one. This one is 2017. This is question 7, part D and part E, okay? So this is where they give you this reaction here. This N2O4 gives us two NO2s. It tells you that this is colourless and this is dark brown. And again, I've written out the Kc equation. I think it always helps to have it in front of you. And for part D, they say the colour of the equilibrium mixture is paler at 0 degrees than at T, where T is greater than 0 degrees. Explaining your reasoning, deduce whether the decomposition of nitrogen tetroxide into nitrogen dioxide is an exothermic or an endothermic reaction. Okay, so what are they asking us? They're basically saying when it's cooler, it's colourless, right? So what's happening? As we cool it down, if we can assume it's paler, that means it's producing more of this. So we're cooling it down and it's producing more of this. That tells us that this direction, as in right to left, is exothermic because according to Le Chatelier, it's trying to offset that change. So as we cool it, it's heating up. So it's producing more of this, which means that this direction, right to left, must be exothermic, which means this direction, left to right, must be endothermic. Does that make sense? So because we can see that if we cool it down, it gets paler, well, then the getting paler direction must be exothermic to offset that getting cooler change. So the other direction must be endothermic. So it's endothermic and it's opposing the change by producing more of the N2O4, the exo side. All right, so that's all you need to say is that it's endothermic. It's opposing the change that you're making to the system, in this case, with temperature. Right, part E then says, would there be a change in the value of Kc at T if a different initial concentration of dinitrogen tetroxide were used? So if we use a different concentration of this stuff at the start, do we change Kc? And the answer is no, Kc doesn't change. It doesn't matter what concentration you start with. By the time it gets to equilibrium, it will have reached the same Kc. Kc only ever changes with temperature, okay? It doesn't change with concentration. It doesn't change with pressure. So the amount at the start that you have is completely irrelevant. Is that okay? Right, I want to do one more, and the last one we're going to do is from 2015. Okay, so 2015, sorry, I'm just getting it up here. 2015 is there. So this is question 11. Part B from 2015, and it looks deceptively simple at the start. There's A and B. A produces B and C. You're not told what they are. They're all gases. We're told that. And there's this little graph here, and the graph tells us, I've just copied this from the question. Again, you can pause the clip at any stage and look at it, obviously. As the temperature increases, Kc increases. We can see that. And just to help me, I always write out this. I find that helpful to write out Kc for myself, right? So There's a calculation on that, which I'm not doing here. That's not the point. The point is to look at Le Chatelier. So it just says the graph shows the relationship between temperature and Kc for this equilibrium. Deduce whether the dissociation of gas A is exothermic or endothermic and explain your reasoning. Right. So what happens? As the temperature increases, Kc increases. Okay, so what do we know? If Kc increases as temperature increases, that means we're producing more B and C. Isn't that right? So if we're producing more B and C, that means that the reaction must be offsetting that change in temperature. So as we increase the temperature, it's going to produce more of the endothermic side. It's going to try and cool the reaction down. So if Kc is increasing, which it is according to our graph, well then we must have more of these guys than we do of this. So that tells us that this reaction is endothermic. We're producing more B and C to offset that increase in temperature. So this reaction, as it's drawn left to right, is an endothermic process. Okay, the second part is to explain how an increase in the storage temperature would affect the pressure of the equilibrium mixture. So if we increase the pressure, what's going to happen? What's going to happen is that we're going to increase the concentration. But what's going to happen is, according to Le Chatelier, as we increase the pressure, as we increase the temperature, the pressure will increase, according to Boyle's law, right? So we increase temperature, we'll increase the pressure, but it will try and offset that by producing more of the side where there's less moles of gas, okay? So you can see here, there's 2 moles of gas here, isn't there? One of these and one of these, but there's only 1 mole of gas here. So if we increase the temperature, the pressure will increase. If we increase the pressure, the system will try and offset that change by reducing the pressure, so we'll get more of A produced, so it will produce more of A overall. Okay, so we'll end up with more of the A produced at the end of the reaction. Okay, so look, I hope that helps. It's just a couple of examples. It's a difficult one to do like this, but I'm trying to show you the thought process, I suppose, that goes into answering questions on Le Chatelier. Like I said, with this topic, there's a bit of everything, a bit of learning, a bit of understanding, a bit of practicing. So hopefully you found that useful. Like I said, in the folder, there's slides and I'm talking through them. So hopefully that helps too. All right, thanks. Bye-bye.